Okay, so we want to continue discussing energy and the energy that we see flowing through our plants. And so let's recap what photosynthesis is. Photosynthesis is when photosynthetic organisms, so organisms that can conduct photosynthesis, are plants, they capture energy from the sun, and they do this utilizing pigments. And so photosynthesis occurs on a leaf, and a leaf's main job is to maximize the light that gets absorbed and the carbon dioxide that's diffused into the leaf. So you probably are aware that plants utilize carbon dioxide in the air for photosynthesis, and plant leaves are really great for maximizing that absorption of light. And you can see that surface area, it's flat, it's not circular, it's very flat. So that flatness allows for lots of sunlight to come in and hit our plant, and so we can take that light energy and turn it into something that the plant can use. So let's take a look at light. Light is energy from the sun that travels to the earth, and we can actually see that sunlight is a mixture of many different wavelengths that are actually visible. So if you look at this wavelength spectrum right here, this is the light spectrum, and within the light spectrum, this is what is visible. So a wavelength of 400 to 750 nanometers, right, nanometers, right there, that is visible light. So if you see a rainbow, you're able to see the reflection of all the different wavelengths within that rainbow. And we'll talk about when you cannot see every color. So if you see the color green or you see the color orange, what colors are being absorbed, and what wavelengths are being absorbed, and what colors are being actually reflected. And let's talk about pigment. Our plants do have pigment, and pigment is something within our plants. There's other things that contain pigments, but these are light-absorbing molecules. And we can use pigments, or I should say that we see pigments used to gather our sun's energy. So let's talk about two types of chlorophyll, our pigments within our plants. We have chlorophyll A and chlorophyll B. Both of these absorb light at about the blue, violet, and red region of our wavelength spectrum, but not within the green region. What's happening with the green region is that it's actually being reflected. The wavelength of green, that particular number, is being reflected, and that's why we can actually see a green plant. I've got a plant right here, and so the fact of the matter is, it's kind of dusty, but I can see that these leaves are green, and it's because the green itself is being reflected, and that reflection is going into my eye. And we have the blue and the violet and the red regions that are not being reflected, but they're actually being absorbed into that pigment, so we cannot see those colors. All right? Now, let's look at this concept on a graph. We've got within our graph right here, we have the absorbency, the percentage of the wavelength that's being absorbed, and the x-axis, we have the wavelength. So you can see right here, chlorophyll A is the blue line, chlorophyll B is the green line. You can see in this region right here, see these peaks? These two peaks are where we're getting absorbency. So the percentage of absorbency is high for the violet and blue region, as well as the reddish region. But look at this region right here. Let's see if I can get a different color pen. Okay. Right here. At about this area, we're not having any absorbency. We're actually having reflection. There is nothing, hardly any percentage of absorbency of these colors, so that's why it's reflecting back into our eyes. And lastly, sorry I had to change where I'm at. I had to run home real quick. But we can look at something like carotene. And carotene is a pigment that absorbs light in a different region of the spectrum. And so we have carotene represented with the orange graph, and you can see that the absorbency is happening within the violet and blue regions, and then pretty much from a little bit of green, yellow, orange, and red, we are having that reflected back. So an example of this would be a carrot. A carrot contains lots of carotene, and that's why we see it as orange. The violet and the blue are being absorbed, and the color orange and the reds and the yellows that are mixed together, they are reflecting back to us as something that is orange. Now consider leaves that are different colors. We know that leaves don't always stay green. They begin to change colors, especially in the fall when it gets cold outside. Well, as the temperature's dropping, we actually see the green from the chlorophyll getting overwhelmed by other pigments. And so what happens is the chlorophyll molecule is actually beginning to break down. And therefore, that reflection of the green color is no longer occurring, and we're actually starting to see the reds and the oranges and the yellows being reflected. And so that's kind of how we can get that variance within color pigments when we look at leaves. And that's it for this lesson, so I will see you guys later.